Well, the milk as a biological product varies with mom's diet, varies with the gestational age of the baby, and subsequently the postnatal age of the baby, mom's overall health in general. While it's quite a perfect balance for rearing the human animal, it does change. And similarly, the baby's needs change. So by evolution, it sort of makes sense that mom's milk product, milk content changes over time, the protein carbohydrate proportions change over time, and that would be reasonable for a baby. What's unusual about the circumstances in preterm babies is that essentially none of the babies that we're dealing with today in a modern newborn intensive care unit can survive without the support of a modern newborn intensive care unit. The ventilators, the nutrition, the antibiotics, all the devices we have. So while evolution might have been ideally suited in changing breast milk to adapt to the postnatal age of the child and gestational age of the child, we didn't evolve to have all that technology to alter that relationship. And so the need is increased because of the technology, because of the ability to grow human beings in an environment outside the womb. We need more and greater understanding of what we're actually using to grow those people. I like making that point because some of our tiniest babies are as small as 9 ounces, 287 grams. And that neonate wouldn't leave our hospital until growing 6 times their size, or almost 10 times their size. And when you think of growing people, if you say it as growing people, you think of that kind of a change, we really should make a great emphasis on getting it right. And if we paid attention to a garden just to grow our vegetables and realize how much effort goes into trimming and maintaining and watering and nutrient intake for the garden, there's things that change over time for humans as well. So the need to measure what's in the milk, breast milk, is critical. While we can make a formula and we know exactly what we put into it, that also would need to change over time. But in the ideal world, if you took the breast milk for all the beneficial effects it has on the immune system, brain development, and maturation, and you were able to adapt your additives to optimize the nutrient needs of the child, let's say for calcium or phosphate, vitamin D, well then that breast milk would be augmented further to be even better suited for the postnatal age, the gestational age, and the disease state of that baby. Well, traditionally, when we grow babies, we've always thought about that as growing the linear size, the weight, the head circumference. And more contemporarily, we're talking a lot more about neurodevelopmental outcomes and immune development and gut flora. But I think what we haven't considered well is the fact that the industry currently is designed to address deficiencies, to prevent rickets, to prevent vitamin E deficiencies so you don't have hemolysis. And I think what we need to rethink our utilization of enteral nutrient as not just as a method of preventing deficiencies, but as a method of signaling normal biological changes. That when proteins are broken down to the peptide stage, they become very potent signals to release of neuroendocrine hormones in the intestine. And those hormones can also affect things like blood flow, enzyme release, but also enter back into the circulation and affect cognitive function, brain development, other organ function. In some work we've been involved with, we've shown that animals that are reared without bacteria, so right from birth, gut biome is completely missing, are missing a common byproduct of fermentation in the gut, short-chain fatty acids, and specifically butyrate, butyric acid, 4-carbon chain short-chain fatty acid. And that 4-carbon chain fatty acid actually has a area of the gene that is called a regulation region. So an upstream regulatory element that interacts with a downstream element to augment the production of an enzyme that helps create catecholamines, adrenaline, noradrenaline. Now, the reason that's so very important in the newborn period is that the evidence that we've accumulated and recently published was that the ability to respond to a common stress, let's say hypoglycemia or even hypoxia, would be augmented by the presence of butyrate, which is a byproduct of colonization of the gut and fermentation of milk. So in the absence of milk, fermentation, butyrate, the ability to produce catecholamines and respond to stress would be diminished. And that's the evidence we've accumulated specifically for hypoglycemia, which is a very common problem in preterm babies and infants of diabetics. So not only are we thinking as the future that we need to have a greater understanding how the enteral diet is not only a nutrient source, but a biological signal for other biological functions. But which of those biological functions affect what other organ, and how does that actually work? So I think it's incredible that a dietary nutrient can alter gene expression and gives great credence to mom telling you don't eat chocolate before dinner, or every time he eats chocolate he has a behavioral problem. Those kinds of things where there's probably some truth in those stories about how we're actually influenced in our behavior by the diet we receive.